Okay students, let us try to solve this question. It says using SPD notations, describe the orbital with the following quantum numbers. Okay, so in all they have given you the values of principal quantum number n and azimuthal quantum number L. Okay, so let us write n and L, and they are asking you to find out or describe the orbital. So okay, let us take the orbital here. Now for A question is you are having value of n as 1 and your value of L is 0. Okay, so let us try to understand these things. Now they are asking you to find out the type of the orbital. Now we are aware of one thing, that when value of L is 0, 1, 2 and 3, corresponding orbitals for it would be S, P, D and F. So with this particular question becomes very easy. Now value of principal quantum number is when n, value of your azimuthal quantum number 0, then it corresponds to orbital S. So your orbital in all with n is 1 and L is 0 will be your 1s. Okay, similarly if you look for B, where your value of n is 3 and L is 1, so principal quantum number would be 3, but for L as 1 the corresponding orbital is P, so the orbital would be 3p for the given condition. Now the C question number, where n is equal to 4 and your L is equal to 2, so 4 is the principal quantum number. For L when corresponds to 2, orbital would be D. So for your third question, for n is equal to 2 and L is equal to, n is equal to 4 and L is equal to 2, your orbital would be 4D. Okay, fine. Now you have one more of the similar type where n is 4 and L is 3. So you can see here I have shown already, when L is 3 it corresponds to your F orbital. So finally here you have 4F. That is the way these orbitals can be written. For your A it is 1s, for B 3p, for C it is 4D and for it is 4F. Fine. Now let us also proceed with the second question given in the same slide. Question number 30. Explain, giving reasons, which of the following sets of quantum number are not possible. So we need to discuss which are not possible. Let us try to discuss every set one by one. The first set says n is 0, L is 0, m is 0 and ms is plus half. Here n is principal quantum number, L is azimuthal quantum number, ml they have given as magnetic quantum number, and this last one is spin quantum number. So now, is this set of 4 possible quantum number is possible or not? That is the question they are asking. So for first one, let me tell you, it is not possible. It is not possible. Now why it is not possible is because value of n cannot be 0. Not possible as n is principal quantum, cannot be 0. Okay, n value is actually starting from 1, 2, 3 like this, so it does not have value of n as 0. So this is the first one is not possible. Fine. Now let us go to the second one, where you will see that you are having value of n is 1, L is 0, m is 0 and spin quantum number is half. Now this is possible. You can see that for value of when n is 1, L can have value 0, right? In fact it has only value as 0, because we know that value of L ranges from 0 to n minus 1. So when n is 1, value of L will be 0 only. So this is possible. Now let us look at the third one. Third is n is equal to 1, L is 1, ml is 0, spin quantum number is half. Now one thing here to note is, when n is equal to 1, I just now told you about, when you put n as 1, value of L would be 0 only. L is equal to 1 value is not possible. Okay, so this set of quantum numbers is not possible. So the reason we mention is it is not possible, right? because if n is equal to 1, then L is equal to 1 is not possible, as values of L range from, as I told you above, 0 to n minus 1. Okay. Now let us look at the another one, D. So for D question, n is 2, L is 1, magnetic quantum number is 0, spin quantum number is minus half. Okay. So for your D, this is possible. D1 is possible because you can see that if your n is 2, your value of L will be 0 and 1 using this particular formula to find out the values of L. So D is possible. Fine. Now E, when you look at, it is exactly like the C, this C. When n is 3, L can't be 3, is because L will be 0, 1, 2 only, using again this formula. When you put up the value of n as 3 here, then 3 minus 1 will be 2. So value of L in this case, L value can be 0, 1 and 2 only. So 3 is not possible. So again this is not possible, and the reason is like that what you have written in your C point. When if n will be 3, L cannot be 3. Okay. Then if you will see for F question, n is 3 and L is 1. So now when n is 3, you put up 3 here, 3 minus 1 would be your 2. So value of L can be 1. So this is again, this last one is possible. Okay. Now you can see that C and E, both of them are same. So here let us conclude one thing. What? The value of N and L when equal are not possible. So equal values, note, equal value of N and L are not possible. This you keep a note of it, and the reason is this which I have just now explained above. I hope it is understood. So the things which are not possible out of A, B, C, D, E are: A was not possible, C was not possible, D was not, E was not possible. Okay. I hope it is understood. Now let us proceed with one more question, and it is a simple question. How many electrons in an atom can have the following quantum numbers? So the question goes, how many electrons in an atom can have these quantum numbers? Now here, total number of electrons we can find it out with the help of one formula, and that is 2n square. So here your n is 4. So let me put here 4 square. You will get 2 into 16, and that is 32 electrons. Okay. Now for n is 4, electrons are 32. But you need to satisfy the other spin quantum number also is given as minus half. Now when you talk about this 32 electrons for orbit number 4, then half of the electrons are having plus half spin quantum number, and another half will have minus half spin quantum number. So what we do is, therefore we divide 32 by 2, we get back 16. So 16 electrons are there which will be having this value for n is equal to 4 and spin quantum number as minus half. I hope this part of 16 electrons is understood. Why it is not taken 32 is because 32 electrons will have both the types of plus half spin and minus half spin. So we divide by 2 because half of them are going to have plus and half of them are going to have minus half values. So total number of electrons they are asking, which we have found out 16. Now let us try to do the second part of the question here. That is very simple. N is equal to 3 and L is equal to 0. So when N is equal to 3, you will have 3, and when L is equal to 0, 0 value of L corresponds to s orbital. This we have already studied. So when L value are 0, 1, 2, 3, then orbitals associated with them are s, p, d and f. So here when value of L is 0, it corresponds to s orbital. So you are having this as 3s orbital. And now the question is how many electrons can be accommodated in 3s orbital. So we know finally only 2 electrons can be accommodated. So I think all the 3 questions which we have done right now are easily understood to all of you. With little formula you need to remember. You need to remember certain things which will definitely help out to do you all these such type of questions. Thank you all.